This video takes a look at working normal distribution problems with the pnorm function. In this video, I'm going to work 3 problems that ask you to find the area under a normal distribution. These are typical of some of the questions on the homework and the exams. In the first problem, we're told the fill weight of a certain brand of cereal is normally distributed with a population mean of 910 grams and a population standard deviation of 5 grams. If we randomly select one box of cereal from this population, what's the probability that it will weigh less than 900 grams? The first thing I always do with questions like this is to sketch out the distribution and shade the area I'm looking for. In this question, we know the mean is 910, so the distribution will be symmetrical with 910 under the peak of the distribution. We want to know the probability the box will weigh less than 900 grams. 900 is less than 910, so draw a mark along the horizontal axis somewhere less than 910. You don't have to be super precise here. You're just trying to conceptualize what the distribution in the area look like. Here's the situation. The standard deviation is 5, so 900 is 2 standard deviations below the mean, and the shaded area is the area we're looking for. The area less than 900 is the probability of getting a box that weighs less than 900 grams. Here's the R code to find this area. Recall pnorm finds the area under a normal distribution. There are 4 arguments. Q is a point along the x-axis. Mean is the population mean. SD is the population standard deviation. And the default for lower dot tail is true, which means a lower tail area is found. In this problem, Q is 900, the mean is 910, the standard deviation is 5, and we're looking for the lower tail area, so we can leave the lower dot tail argument out and use the default value of lower dot tail equals true. The area shown in the red box is the answer. It's about 0.0228. The next problem says the miles per gallon for a mid-sized car is normally distributed with a population mean of 32 gallons and a population standard deviation of 8 gallons. What's the probability that the MPG for one car randomly selected from this population would be more than 32.2? Once again, the first step is to sketch out the distribution and shade the area you're looking for. 32.2 is greater than the mean of 32. So this point will be higher than the mean, and we're looking for an upper tail area. Here's the distribution. I've shaded the area above 32.2, and that's the area we're looking for. Here's the R code to solve this problem. Q is 32.2, the standard deviation is 0.8, the mean is 32, and we're looking for an upper tail area, so we've got to have lower dot tail equals false. The answer is in the red box, 0.4013. The third question tells us a population has a normal distribution with a population mean of 110 and a population standard deviation of 11. If we randomly select one observation from this population, what's the probability that it will be between 108 and 115? When we sketch out this problem, start out with a symmetrical distribution with 110 in the middle as the mean. One of the 2 points we have is 108. This is less than the mean, so draw a mark somewhere below the mean along the x-axis. The second point is 115. This is greater than the mean, so draw a mark on the x-axis somewhere above the mean. The area between these 2 points is the answer. Here's how to solve this. First, find the area below 115. Next, find the area below 108. And finally, subtract the area below 108 from the area below 115. Here's the distribution, and I've shaded the area between 108 and 115. Here's the R code. Notice I used pnorm to find the area less than 115. And there's a box drawn around that pnorm function. I then subtracted the pnorm to find the area less than 108, and there's a box around that pnorm function as well. The difference between these two pnorm functions is the answer, about 0.2474. We looked at three kinds of problems using pnorm. First, the probability that x is greater than some number. Second, the probability that x is less than some number. And third, the probability that x is between two numbers. Thanks for watching. Please let me know if you have any questions.